Tonight, we're setting off on a gentle voyage above the rooftops and into the velvet dome of the night sky. Along the way, we'll follow the soft sparkle of distant stars and explore a question whispered by dreamers for generations. Why do stars twinkle? Now, this little journey is meant to ease you into rest, to be the kind of story that lets your mind float and your eyelids grow heavy. But just a heads up, the cosmos has a way of being quietly fascinating. And if you find yourself too curious to sleep right away, well, lying awake with a head full of starlight isn't such a bad trade. Before we begin, if you wouldn't mind giving that like button a gentle tap, it helps guide other wandering minds to this cozy corner of the universe. And if you haven't already, consider subscribing to keep the night sky within reach. I'd also love to know, where in the world are you watching from? What time is it there? Are you just tucking yourself in? Or has the night already wrapped around your home like a soft, invisible quilt? Tell me in the comments. I'm always curious to know where starlight finds you. Now, wherever you are, whatever time it may be, let's get comfortable, breathe deeply, and turn our gaze upward. The stars are waiting. Let's begin with something simple. Something you've probably wondered while staring into the night. Why do stars twinkle? You've seen it. A point of light shimmering gently in the vast, dark sky, winking as if it's in on some cosmic joke. It's enchanting, mysterious, and oddly soothing. But what's behind that flicker? What makes a star sparkle like a jewel tossed onto black velvet? Here's the twist. Stars don't actually twinkle. Not really. If you could drift above Earth's atmosphere and gaze at the stars from space, they'd appear calm and steady. No flickering, no shimmer. Just unwavering beacons of distant fire. So if the stars themselves are steady, the twinkle must come from somewhere between them and us. And it does. The true culprit? Earth's atmosphere. That delicate, invisible shell of air that wraps our planet. You see, starlight travels an almost unimaginably long distance through the silent vacuum of space without the slightest tremble. But in the final 100 kilometers of its journey, everything changes. Our atmosphere is not still. It's a swirling ocean of air, layered with different temperatures, densities, and moisture. It shifts and ripples, gusts and churns. Imagine it like a giant transparent lava lamp, mesmerizing but never quite calm. As starlight enters this chaotic sea of air, it bends. This bending of light is called refraction. You've probably seen it when a straw looks oddly broken in a glass of water. The same principle applies here, only the complexity is multiplied a billion times. With every layer of turbulent air it passes through, the light is nudged this way and that, zigzagging ever so slightly. By the time it reaches your eyes, that steady point of light looks like it's shimmering, dancing. It twinkles. This phenomenon even has a name that sounds like a spell from an ancient book, stellar scintillation. It's a poetic term, but entirely scientific, describing the shimmering of starlight caused by atmospheric turbulence. But not all stars twinkle equally. Some flash brightly, some flicker gently, and a few seem almost still. Why? It has to do with where they are in the sky. Stars near the horizon twinkle more dramatically than those directly overhead. That's because their light has to pass through more of our atmosphere, a thicker slice of that swirling air ocean. More air means more bending, more distortion, more sparkle. It's the difference between looking straight up into a clear sky and squinting across a hot road shimmering in the heat. So the next time you look up and see a star winking at you, remember, it's not the star that's moving. It's the air between you and it. A shimmering river of turbulence that turns steady light into cosmic glitter. And maybe, just maybe, it's the universe's way of saying goodnight. Still, even at their steadiest, there's usually a gentle shimmer to them, a subtle flicker like a candle far across the room. Now, here's something interesting. Planets don't twinkle like stars do. If you've ever looked up and spotted a bright star that seems unusually steady, chances are you are actually looking at a planet. Maybe Venus or Jupiter. Planets shine with a calm, unwavering light. Why? It all comes down to size, or rather apparent size. Stars are so far away that they appear to us as infinite decimally small points of light. All their brightness is packed into a single sharp dot. So when the atmosphere shifts that dot even a little, you see a twinkle. But planets being much closer to Earth appear as tiny disks in the sky. Still small, yes, but not point-sized. So even when the atmosphere distorts the light coming from a planet, the effect is averaged out across its wider shape. The flickering cancels itself out. The result, a calm, steady glow, like a flashlight through a foggy window, instead of a pin-prick laser through smoke. Of course, this wasn't always understood. For most of human history, people saw twinkling stars as something magical, even alive. Some cultures believed they were ancestors watching from above, their eyes glinting in approval or judgment. Others imagined they were lanterns lit by gods trembling in the night wind. The word twinkle itself feels whimsical, doesn't it? It's a soft, lyrical word. It dances off the tongue. That's probably why it found its way into lobbies and nursery rhymes. Twinkle, twinkle, little star being the most famous. A simple question from a child song that even adults find strangely profound. But beneath that childlike wonder is a world of physics and atmospheric science quietly humming away every night. It's the same starlight that guided sailors across oceans, inspired poets and astronomers, and helped early civilizations mark the passage of time. And all the while it twinkled more because of Earth and the stars themselves. One more little twist. Stars don't all emit the same kind of light. They have different temperatures, and that means different colors. Hotter stars shine blue or white. Cooler stars shine red or orange. Sometimes when the atmosphere gets especially unstable, say on a hot summer night, you might notice stars flickering with flashes of different colors. That's the atmosphere playing tricks with wavelengths. It's a bit like looking through a prism that's constantly wobbling. You're seeing momentary glimmers of starlight separated into its colors before, snapping back together again. So the next time you look up at a twinkling star, remember this. It's not just a distant sun dancing for your amusement. It's a message from the cosmos, one that's traveled across millions of years and unimaginable distances only to get its final polish from the air above your head. It's a mix of cosmic elegance and earthly chaos. Light that began its journey before humans learned to farm, flickering now because of a breeze you can't even feel. Isn't that strangely comforting? So, let your thoughts float up there with the stars for a while. They'll shimmer and flicker for you, just as they've done for every soul who ever looked up and wondered. If the stars themselves are steady, then what's really making them twinkle is the journey their light takes through Earth's atmosphere. And that atmosphere, oh, it's a busy, bustling place, even when it looks calm. It may seem invisible and still from down here on the ground, but in reality, it's a constantly shifting ocean of gases, always swirling and stirring. To understand why the sky above us shimmers the way it does, we need to take a slow, peaceful dive into the layers of air that wrap around our world. Let's start with a soft descent, or perhaps more accurately, a gentle ascent. The atmosphere is made up of several distinct layers like a giant cosmic cake. From the surface of the Earth upward, these layers are the troposphere, the stratosphere, the meosphere, the thermosphere, and the exosphere. Each one plays a role in shaping the journey of starlight. But the one that makes the biggest difference, the one responsible for most of the twinkling, is the troposphere. The troposphere is the layer of atmosphere closest to the Earth. It stretches from the ground up to about 6 to 10 miles high, depending on where you are. If you have ever flown in an airplane, you've spent time in the upper parts of the troposphere, sipping tomato juice, and hoping your luggage didn't end up in a different time zone. This layer contains most of the air we breathe and nearly all of the weather we experience. Clouds, winds, rain, snow, turbulence, and those slightly judgmental seagulls at the beach. The troposphere is like a planetary mixing bowl. It's full of temperature differences, moving air currents, and little whirlpools of heat and moisture. And when light from a star passes through this churning soup of air, it bends. Sometimes it bends just a little, sometimes a lot, but either way it bends. And that makes the star appear, to jiggle or flicker. Now let's talk about refraction, but gently. Refraction is what happens when light changes speed as it moves from one substance to another. Say from the vacuum of space into the dense air of Earth. Light travels fastest in a vacuum, slower in air, and even slower in water or glass. That change in speed causes the light to bend. You've seen this before, probably without realizing it. If you've ever dipped a spoon into a glass of water and noticed it looked like it snapped in half at the surface, you've witnessed refraction. Or maybe you've stared at the wavy lines rising from hot pavement on a summer day. Same thing. That shimmer, that ripple, that's light being bent by the heat-distorted air. In the atmosphere, refraction happens all the time. But the atmosphere isn't a single sheet of uniform air. It's made of countless little patches, each with its own temperature, pressure, or heat and moisture content. These differences create pockets where the air is slightly more or less dense. And starlight gets bent every time it passes through one. Think of it like this. Imagine you're looking at the stars through a calm swimming pool. If the water's still, you see the stars clearly. But now imagine someone doing cannonballs nearby. Every splash, every ripple changes the way the water moves. The stars begin to shimmer, stretch, and wiggle. The atmosphere does the same, only with less splashing and fewer inflatable flamingos. Now, while the troposphere does most of the heavy lifting when it comes to twinkling, the higher layers contribute to the stratosphere, which sits just above the troposphere, is calmer and less turbulent, but it still has temperature gradients that can affect the path of starlight. The mesosphere above that, where meteors burn up, adds a final sprinkle of refraction, especially for stars near the horizon. The higher up you go, the thinner and colder the air becomes. But even these faint, icy layers can wiggle the light just enough to add to the twinkling effect. It's a bit like adding extra layers of frosted glass over a lamp. Each one adds a new flicker, a new shimmer until the final glow reaches your eye with that familiar, comforting seagull. Now, an important detail. The way the atmosphere bends light doesn't just cause twinkling. It can also shift the apparent position of stars slightly. If you were to track a star's location over time without correcting for atmospheric effects, you'd find that it dances in tiny, unpredictable patterns. Astronomers have known this for centuries. That's why serious stargazing, especially the scientific kind, involves all sorts of clever tricks to see through the atmosphere. But before we get to telescopes and space observatories, let's return to the poetic side of this dance. Because in a way, Earth's atmosphere turns every clear night into a kind of living light show. Without it, stars would shine with perfect steadiness. Beautiful, yes, but perhaps lacking that little touch of magic. There's something quite charming about the fact that the stars twinkle. Not because of what they are, but because of where we are. It's a very human phenomenon, twinkling. It exists only from our point of view, shaped by the air we breathe and the world we inhabit. It's a reminder that even as we gaze out into the cosmos, our experience of the universe is filtered through the lens of home. And here's a curious little fact. Not all twinkling is created equal. On some nights, the stars seem to glitter wildly. On others, they hardly twinkle at all. That's because atmospheric conditions vary constantly. Calm, still air, like on a cold winter night, reduces turbulence and makes the stars appear steadier. On a hot summer evening with rising warm air and gusts of wind, the twinkling can be especially lively. In fact, experienced stargazers and astronomers often rate the seeing conditions of the night sky based on how much the stars are twinkling. Less twinkle usually means better conditions for telescopic observation. But for the casual dreamer lying on a blanket, a little extra shimmer never hurt anyone. So the next time you look up and see a star flicker gently in the dark, remember the invisible ballet happening above you. The layers of our atmosphere, so often taken for granted, are in constant graceful motion. They bend the light from ancient stars, sculpting it into a delicate dance just for your eyes. It's as if the sky is breathing in, out, each breath shifting the starlight just enough to make it sparkle. And all of this, every twinkle, every flicker is made possible by air. The same air that carries the scent of Rain, the rustle of trees, and the quiet hush of night. It's not just a medium we move through. It's an artist painting the stars with emotion and life. And here you are wrapped in that same air, watching the sky do what it's done for billions of years. Twinkle just for you. Let's imagine something rather beautiful for a moment. Somewhere out there, unimaginably far from Earth, a star is burning, steady, relentless, ancient. It may be older than our planet, older than our sun, older than the very concept of time as we understand it. And from that star, a single particle of light, a photon, is released. It begins a journey, not just any journey, but one that will span vast cosmic distances and billions of years. Also, it can one day flicker in your eye for the briefest of moments. That's the story we're following now. The life of a photon from star to sky to you. Photons are tiny packets of light. They have no mass. They travel at the speed of light. And once they're set in motion, they don't slow down, veer off, course, or get tired. They are the ultimate long-distance travelers. And they begin their journey deep inside the rowing heart of a star. Take a star like our sun, for instance. Deep within its core, nuclear fusion is constantly turning hydrogen into helium, releasing enormous amounts of energy in the process. Some of that energy becomes heat, some becomes radiation, and some becomes photons, little messengers of light that have to fight their way to the surface. And when I say fight, I mean really fight. A photon born in the core of a star might bounce around inside that star for tens of thousands, even hundreds of thousands of years. It doesn't move in a straight line. Instead, it gets absorbed and remitted by atoms over and over again, zigzagging like a moth at a disco until it finally escapes the star's surface and breaks free into space. Once free, the photon begins what might be the smoothest part of its journey, coasting through the near-perfect vacuum of space. Out here, there's very little to get in the way. No atmosfera, no clouds, no turbulência. Just emptiness, darkness, and the occasional planet or dust cloud. A photon can travel for millions, even billions of years without colliding with a single thing. That means the light you're seeing from some stars tonight began its voyage long before the first humans walked the Earth. Let's pause on that for a moment. If you're looking at a star that's, say, 100 light-years away, the light from that star began its journey around the year 1924, back when people were still driving. Model T Fords and Jazz was just hitting its stride. That photon was already en route. And now, tonight, it finally arrives, only to get knocked around in our atmosphere and made a twinkle. A dramatic finish for a very patient traveler. Now, space isn't completely empty. Along its path, a photon might pass through clouds of cosmic dust, magnetic fields, or gravitational distortions caused by massive objects like black holes or galaxies. These encounters can bend the photon's path, slow it slightly, or scatter it. But for the most part, space is generous and lets light pass freely. Some photons do get diverted or absorbed, of course. That's why not all starlight reaches us. Some never make it past distant gas clouds. Others are captured by planets or swallowed by the void. But for the few that do find their way here, the final stretch of their journey is the most treacherous of all, our atmosphere. We talked about how the atmosphere bends and distorts light in the last chapter. But let's look at it now from the photon's point of view. After sailing serenely through the vacuum of space, our photon now hits a swirling sea of molecules. It enters the atmosphere and vessel. It's like trying to run a straight line through a crowded room of dancing people. The photon gets jostled, nudged again, his path bending slightly this way, then that. The result, when it finally hits your eye, is a little wobble in its apparent position, a twinkle. And speaking of hitting your eye, let's not gloss over how amazing that is. Your eye is made up of millions of light-sensitive cells, and in perfect darkness, it's sensitive enough to detect even a single photon. Yes, just one. If your surroundings are dark enough and your eyes are fully adjusted, you might actually see the impact of one lonely particle of light that's traveled across space for millennia just to say hello. And when that happens, your brain interprets the signal as light from a star that to you has always been there, always twinkling. But really, what you're seeing is a brief interaction between a particle and a person, a handshake across the cosmos. It's easy to forget sometimes that starlight is not just a glow in the distance. It's a physical thing. It's matterless, but not meaningless. Every flicker you see is a story, a fusion, of survival, of time and distance. It's like the star is whispering something to you, and the universe is bent over backward to deliver the message. In astronomy, there's a term for this kind of journey, the light path. It describes the route that photons take from a celestial object to our instruments or to our eyes. Understanding the light path is crucial because it helps astronomers determine how much of what they see is due to the object itself and how much is due to the distortions along the way. In a way, when you're looking at the stars, you're not seeing the present. You're looking into the past. The farther away a star is, the older its light is by the time it reaches you. That means the sky is a kind of living time machine. Every star is a snapshot of what it looked like years, decades, centuries, even eons ago. And yet, we experience that light now in this moment. It's a curious paradox. Light from the past illuminating the present. You lying there gazing at the stars are participating in an ancient ritual. People have done this for tens of thousands of years, long before the science of photons or the word twinkle ever existed. And while the language and understanding may have changed, the feeling hasn't. The awe, the stillness, the sense of wonder, they've stayed the same. So the next time you spot a twinkling star, pause for a second and consider what you're really seeing. You're witnessing a photon's final destination. After a lifetime spent racing across space, dodging dust and gravity, it ends its journey not in a telescope, not in a lab, but in your eye. It's a gentle reminder that the universe is vast, ancient, and wild, but it's also personal. You're not just an observer. You're part of the story. You lying there with your thoughts are the final chapter in a photon's cosmic journey. And if that doesn't make you feel both tiny and cherished, I don't know what will. If you've ever looked up at the night sky and noticed that not everything twinkles, you're not imagining things. In fact, you may have already stumbled upon one of astronomy's easiest observational tests. How to tell the difference between a star and a planet. Here's the secret. Stars twinkle. Planets don't, or at least not nearly as much. That soft, flickering starlight, the kind that seems to shimmer like a candle in the dark, is something stars do best. But those bright, steady lights that hang calmly in the sky, those are often planets. And they glow with a quiet certainty, like they're just a little bit more grounded, even though they're floating in space. But why the difference? After all, both stars and planets are shining points of light in the night sky, right? Well, yes and no. Let's start with the stars. Stars are incredibly far away. Even the closest one beyond our sun, Proxima Centauri, is over 4 light years from Earth. That's roughly 25 trillion miles, which is an awful lot of zeros. Because of this vast distance, stars appear to us as infinite, decimally small pin pricks of light. Not dots, not disks, just a single shimmering point. That's important because when a point of light travels through Earth's atmosphere, it's highly vulnerable to all the atmospheric refraction we've been talking about. Each little patch of moving air can bend that tiny light path just enough to make it jump ever so slightly in the sky. 2. Your eyes. That movement appears as a twinkle, a little flicker or flash as the light shifts position or intensity. Now, let's turn to the planets. While stars are burning giants trillions of miles away, planets in our night sky are part of our own solar system. They're relatively close, at least on a cosmic scale. Venus, for example, can come as close as 25 million miles. That's still not exactly next door, but compared to a distant star, it's practically a neighbor borrowing sugar. Because planets are so much closer, they don't appear to us as pinpoints. They may still look tiny, but under magnification, or even just from the way their light behaves, they're actually small disks of light. And here's the key. When light comes from a disk instead of a point, it's more stable. Why? Because even when bits of the light from a planet are bent by the atmosphere, the distortions tend to cancel each other out. One edge of the disk might get bent one way, another edge might go slightly the other way, and the overall effect is a kind of visual averaging. The result, the planet doesn't flicker. It just glows. Imagine this. You're looking through a wavy piece of glass at a candle flame. The flame, being small and sharp, will dance and shift dramatically as the glass distorts the image. But now imagine looking at a larger, glowing light bulb through that same glass. The light bulb still gets distorted, but the overall image remains much steadier. That's the difference between how we see stars and how we see planets. And here's something fun. Once you know this trick, you can go outside on a clear night and put it to the test. Find the brightest star in the sky. Is it flickering, flashing slightly red and blue at the edges, dancing like it's had too much coffee? Probably a star. But if it's glowing with a serene, unwavering light, chances are you've found a planet. Venus is the classic example. Often called the evening star or morning star, it's the third brightest object in our sky after the sun and moon. But unlike real stars, it shines with a smooth, creamy glow. Jupiter and Saturn, too, are often visible to the naked eye and stand out for their steady presence. They don't twinkle. They assert themselves quietly. Now, there are exceptions to the rule. Planets can twinkle, but it's rare and usually only happens when they're very low on the horizon. Because when a celestial object is near the horizon, the light has to travel through a much thicker slice of atmosphere to reach your eyes. Think of it like trying to see something through a very long, slightly murky tunnel. The thicker the atmosphere, the more distortion. So, even a disc-shaped object like a planet can start to flicker a little. Still, in most cases, the difference is obvious. Planets sit steady while stars sparkle. This difference hasn't just helped backyard astronomers. It's helped professional ones, too. Long before telescopes existed, early sky watchers learned to distinguish stars from planets just by paying attention to how they behaved. In ancient times, planets were known as wandering stars because, they moved across the sky relative to the fixed stars. They had their own path, their own slow dance, and then, crucially, it didn't twinkle like the others. Even the ancient Greeks noticed. The philosopher Ptolemy noted that stars had a flickering nature, while planets did not. And over time, this difference helped astronomers map the heavens, track celestial movements, and ultimately understand our place in the solar system. So the next time someone asks how to tell a planet from a star, you can just smile and say, look for the one that isn't twinkling, but the story doesn't end there. You see, twinkling, or the lack thereof, is more than just a visual oddity. It's a reminder that everything we see in the sky is shaped by both what it is and how we're looking at it. The atmosphere, the distance, the angle, the type of object. All these factors come together to create what we experience as the night sky. And that's part of what makes it so endlessly fascinating. The sky isn't a static painting. It's alive, moving, changing, revealing just a little more to anyone willing to stop and look. Planets with their calm glow might not dazzle in quite the same way as their twinkling cousins, but they're no less magical. In fact, once you start noticing them, it's hard not to feel a quiet sort of connection. That point of light, that's not a distant star in another galaxy. It's a world, a place, a real physical body orbiting our sun, lit not from within, but from the reflection of our shared star's light. Some of those planets have moons, some have storms, some have rings, and some, just maybe, have mysteries we haven't even imagined yet. So, while the stars may twinkle and steal your attention with their glittering charm, don't overlook the planets. Their calm, steady presence is a different kind of wonder, one that whispers instead of sings. And as you lie back and look up, letting your eyes wander across that cosmic sea, try to spot the ones that hold still. The ones that don't flicker, but just are. They're not stars. They're neighbors. And in the grand silence of the night, they're keeping you company. Long before we had telescopes, satellites, and space probes, long before anyone knew what a photon was or what the atmosphere even did, humans were watching the stars. Night after night, they gazed up at those twinkling lights and wondered what they were, why they moved, and what their strange shimmering dance could possibly mean. And when we don't yet have science to explain something, we do what humans do best. We tell stories. Every culture on Earth has looked to the stars and spun eyelash around them. Some imagine them as gods, others as spirits, ancestors, animals, or omens. The way stars twinkled, flickering, changing color, vanishing, and reappearing only added to their mystery. To the people of ancient times, this wasn't just the result of warm air and light refraction. It was magic or divine will, or maybe a message from beyond. In ancient Greece, for example, stars were often associated with the gods of Mount Olympus. The shimmering of the stars was said to be the gods playing in the heavens or the light of divine chariots racing across the sky. One particularly bright star might be considered a hero placed in the sky by Zeus himself. The flickering. Perhaps that was the hero winking at his descendants. The Greeks also told the tale of Orion the hunter, who was placed in the stars after his death. When his constellation twinkled brightly in the winter sky, it was said to be him hunting once more, his bow drawn in the shimmering darkness. Meanwhile, in Aboriginal Australian mythology, some of the oldest continuous cultural traditions on the planet, twinkling stars were often interpreted as signs from ancestral spirits. Different communities had just different stories. Some believe that the shimmering stars were campfires of ancestors burning far off in the sky. Others saw twinkling as a way for the spirits to communicate with the living, offering guidance, reassurance, or sometimes warnings. One story from a Yolngu people of northern Australia describes how the stars are part of the dream time, the foundational mythological past when ancestral beings created the world. When stars twinkle rapidly, it's seen as the spirits becoming more active, watching over the people on Earth and keeping an eye on their actions. In ancient Japan, the story of Orihime and Hikobashi explains two bright stars, Vega and Altair, that shine across the Milky Way. According to legend, the two were lovers separated by a heavenly river, only allowed to meet once a year. On that night, if the stars twinkled brightly, it was believed the lovers were especially happy to see each other. If clouds blocked the sky, they cried, and their tears became the rain. Even the Norse, with their mythology rich in giants, gods, and cosmic wolves, had tales of the stars. They believed the sky was a great dome made of the skull of a giant, and the stars were holes through which the light of the celestial fires shone, the flickering of stars. Perhaps those fires burning, crackling softly behind the curtain of night. In Central and South America, the Maya and Inca peoples were keen observers of the stars. They built temples aligned with celestial events, tracked planetary movements, and used the twinkling of certain stars to predict weather patterns. In some traditions, a rapidly flickering star was thought to foretell a coming storm or drought. The sky wasn't just a canvas of stories. It was a living calendar, a warning system, a spiritual map. Of course, not all myths were friendly. In some cultures, a twinkling star might be an ill omen. It could be the eye of a watchful spirit or a warning of war or death. The unpredictable nature of twinkling, how a star might suddenly flare or fade, was unsettling as much as it was beautiful. In parts of West Africa, some communities believe that stars were the spirits of unborn children or the recently departed. Their flickering was interpreted as a kind of communication, a whisper from another realm. The brighter the twinkle, the stronger the spirit. It was a comforting thought that the dead were not gone, just shining above, still keeping watch. And we can't forget the famous North Star, Polaris. It doesn't twinkle nearly as much as other stars, especially when it's high in the sky, which gave it a reputation for steadiness. That made it a powerful symbol across many cultures. To ancient navigators, it was a guide. To spiritual leaders, it was a sign of constancy in a changing world. The fact that it didn't twinkle much was part of its mystique. It was like the one star that kept its cool while all the others danced. Even in more recent times, Twinkling stars have continued to inspire art, music, and poetry. From the classic lullaby, Twinkle, Twinkle, Little Star, to Van Gogh's swirling masterpiece, The Starry Night, we've never stopped being enchanted by those flickering lights above us. And that's what makes twinkling so special. It's not just a side effect of atmosphere. It's a bridge between science and story, between the observable and the imagined. Even now, when we know exactly why stars twinkle, there's still something magical about it. Knowing the physics doesn't take away the poetry. It adds to it. It tells us that our ancestors weren't wrong to see mystery in the stars. They were just looking with a different kind of eye, one that blended observation with wonder, facts with feeling. And in a way, we still do the same. We now understand that a star's flicker is caused by a shifting air and bending light. But that doesn't stop us from making a wish when we see one sparkle. So the next time you find yourself gazing up at the stars and watching them, twinkle, try this. Imagine the stories they've told. Think of all the people who have looked up before you thousands of years ago on different continents with different languages and beliefs and seen the same flicker. Maybe they saw a god, maybe a spirit, maybe a sign of love or loss or hope. You might see something different, or maybe, just maybe, you'll see the same thing they did. A little light, a little motion, a little mystery, and a whole lot of sky. For as long as people have been watching the stars, there have been those determined to understand them. Not just admire them or tell stories about them, but measure them, track them, predict them, and maybe, just maybe, unravel the deeper truths hidden in their shimmer. Enter the ancient astronomers. Long before computers, telescopes, or satellite imagery, there were sky watchers, diligent observers who spent night after night mapping the heavens by eye alone. These early scientists noticed things most people missed: how the stars moved when they rose and set. And yes, how they twinkled. They knew that starlight was not a still and steady glow, but a living, shifting phenomenon. And they wanted to know why. In Mesopotamia, over 4,000 years ago, Babylonian astronomers were already keeping detailed records of celestial events. They built observatories, charted the movements of the moon and planets, and noticed subtle changes in the brightness of certain stars. These early records didn't include technical explanations, no mention of atmospheric refraction or turbulent air, but they did describe the visual experience of a night sky in remarkable detail. When a star flickered erratically or changed color, it was noted. Sometimes it was interpreted as an omen, but sometimes it was just another puzzle piece. The Babylonians weren't alone. Ancient Egyptians aligned their pyramids and temples with the stars, particularly Sirius, whose rising signaled the annual flooding of the Nile. They may not have written about the twinkling itself, but they knew which stars appeared most clearly and which were affected by the haze of the horizon, a subtle nod to the reality of atmospheric distortion. Then came the Greeks, who took things to a new level. The philosopher Anaxagoras, living around the 5th century B.C., he was one of the first to suggest that stars were actually fiery stones far from Earth. Radical stuff at the time. His student Democritus went even further, proposing that the Milky Way was made up of countless distant stars too far to be seen clearly as individuals. These ideas weren't accepted by everyone. Some were downright scandalous, but they planted seeds of thought that would eventually grow into real astronomy. Fast forward a few centuries to Claudius Ptolemy, one of the most influential astronomers of the ancient world. Living in Roman Egypt during the 2nd century CE, Ptolemy compiled a vast work called the Almagest, which included detailed star catalogs, planetary models, and observational techniques. He noted how stars near the horizon flickered more than those directly overhead, and how some stars seemed to flash different colors. He couldn't explain it. No one yet understood light refraction, but he recorded it, and that mattered. Ptolemy's observations were based on thousands of hours spent staring at the night sky, likely with nothing more than the naked eye and some very basic instruments. Arillary spheres, sighting tubes, and careful notes. No lenses, no glass, just careful attention and a lot of patience. And it wasn't just Europe. In the Islamic Golden Age between the 8th and 14th centuries, astronomers across the Middle East and North Africa made enormous contributions to our understanding of the stars. They built observatories in cities like Baghdad, Cairo, and Samarkand. They translated and preserved ancient Greek texts, added their own observations, and refined the accuracy of star catalogs. One of the most brilliant minds of this era was Al-Safai, a Persian astronomer who compiled the Book of Fixed Stars in the 10th century. He made corrections to Ptolemy's data and added his own observations. He also described the color and brightness of stars in great detail, paying attention to changes over time that may have included descriptions of atmospheric effects like twinkling. And then there was Ulugh Beg, a 15th century ruler and astronomer who built one of the largest astronomical observatories of the medieval world in what is now Uzbekistan. His team created a star catalog that rivaled anything Europe would produce for another 100 years. Again, no telescopes, just the human eye, sharpened by discipline and an insatiable curiosity. Twinkling wasn't just a poetic flourish for these astronomers. It was a real obstacle. When stars flickered or shimmered, it made it harder to measure their positional brightness accurately. So, they developed methods to minimize error. Observations were repeated many times over, usually from high elevations where the air was thinner and less turbulent. Some even constructed narrow slits or sighting tubes to reduce the amount of atmosphere the light had to pass through before reaching the eye. Simple solutions, but effective ones. By the time of the Renaissance, European astronomers began to build on this legacy. Tycho Brahe, the brilliant Danish nobleman of the late 16th century, created the most accurate star charts ever made without a telescope. He noticed the twinkling of stars, too, and he hated it. It interfered with his ability to record precise measurements. So he built massive instruments, giant protractors and sextants, to help him refine his observations. He even created a kind of protoservatory on the island of Avon, where conditions were especially good for watching stars. And then came Galileo. In 609, Galileo pointed a telescope skyward and changed everything. Through the lens of his handmade instrument, he saw craters on the moon, moons orbiting Jupiter, and most importantly for our topic, he noticed that stars still twinkled through the telescope, but planets did not. The telescope magnified the tiny disks of planets, confirming what careful observers had already suspected, that twinkling wasn't a property of the object itself, but something happening in the space between. Galileo's findings helped establish that stars are incredibly distant, while planets are much closer. It was a turning point in how we understood the universe, and twinkling played a small but meaningful role in that realization. Today, of course, we have technology that ancient astronomers could only dream of. We've launched telescopes into space above the twinkling atmosphere altogether. We've developed adaptive optics systems that adjust for atmospheric distortion in real time, allowing ground-based telescopes to dinkle the stars, if you will. We can now see stars not as shimmering points, but as stable sources of light, their secrets clearer than ever before. But it's humbling to remember that the foundation of all this began with the naked eye, with someone sitting under the stars night after night, squinting at the flickering lights and wondering what it all meant. The twinkling may have frustrated them at times, but it also inspired them. It made the sky feel alive, just mysterious enough to chase. So next time you find yourself looking up and watching a star shimmer, think of all the eyes that have done the same. From Babylon to Baghdad, from ancient Greece to Renaissance Europe, each generation of sky watchers added a little more to the story. A little more knowledge, a little more awe, and maybe a little more appreciation for the beautiful imperfection of a twinkling star. So far, we've talked a lot about how stars twinkle, what causes it, who's observed it, and the stories we've told because of it. But now, let's step into the present. Let's talk about how modern science handles twinkling stars, especially when twinkling gets in the way. Because as beautiful and poetic as it may be, twinkling is also a bit of a nuisance when you're trying to do serious astronomy. Astronomers don't exactly enjoy squinting at a flickering light show when they're trying to measure a star's exact brightness or track an exoplanet passing in front of its sun. It's like trying to read a book while someone keeps jiggling the pages. So, what does science do when nature throws a glittery atmospheric curveball? It gets clever. First, let's revisit the problem. Earth's atmosphere is constantly shifting. It has layers of different temperatures, densities, and moisture levels, all moving around thanks to winds, thermal currents, and weather patterns. As starlight passes through these layers, it bends or refracts in unpredictable ways. This bending causes the star's image to jump slightly, changing its brightness and even color from one moment to the next. That's the twinkle. For casual observers, anyone lying on their back and looking up at the stars, it's charming. But for astronomers trying to capture a razor-sharp image or measure the precise light curve of a distant galaxy, it's a major obstacle. One solution is surprisingly simple. Go somewhere high. The higher up you go, the less atmosphere you have above you. That means less turbulence, less distortion, and less twinkle. That's why some of the world's best observatories are perched atop mountains. Mount Aya in Hawaii, the Atacama Desert in Chile, or the Canary Islands in Spain. Up there, the air is thin, dry, and often incredibly stable. All of that helps astronomers get clearer views. But even at high altitudes, the atmosphere still moves. And so, technology comes to the rescue. Enter adaptive optics, a clever system that allows telescopes to compensate for the distortions caused by the atmosphere in real time. Think of it like noise-canceling headphones, but for starlight. Here's how it works. Telescopes equipped with adaptive optics use a flexible mirror, one that can subtly change shape dozens or even hundreds of times per second. A laser is shot into the sky to create a kind of artificial star, a reference point. Sensors detect how the atmosphere is distorting the light coming from this fake star. And then computers calculate the necessary adjustments. The mirror responds instantly, bending and flexing to cancel out the distortion. The result, a sharpest image, a steady star, no twinkle. It's a marvel of engineering and computation, and it's allowed ground-based telescopes to achieve clarity once thought impossible without going to space. But of course, sometimes the best way to avoid the atmosphere altogether is to leave it behind. That's exactly what astronomers did in 1990 when they launched the Hubble Space Telescope. Floating more than 300 m above Earth's surface, Hubble operates in the vacuum of space. No atmosphere, no distortion, no twinkling, just pure, undisturbed starlight. The images Hubble captured changed astronomy forever. Swirling galaxies, glowing nebulae, and the faintest light from the farthest corners of the universe came into focus with breathtaking detail. And one of the quiet miracles behind all that beauty, no atmospheric interference. Hubble showed us what the universe really looks like when we strip away Earth's blurry filter, and it was dazzling. Since then, we've sent up other space telescopes like the Kepler Space Telescope, which hunted for exoplanets by detecting tiny changes in starlight as planets passed in front of their stars. Such work would have been nearly impossible from the ground, where twinkling could mask those delicate light dips. And of course, there's the James Webb Space Telescope, a successor to Hubble, launched with the goal of peering even deeper into space and time. It uses advanced infrared sensors and lives far beyond Earth's atmosphere, orbiting at a stable point in space known as Lagrange Point 2. From its vantage point, stars don't twinkle at all. They shine like the steady beacons they are. But not all. Astronomy needs to be done from mountaintops or outer space. Even here on Earth, we can reduce the effects of twinkling through clever techniques. For example, by taking many short exposure photographs instead of one long one, astronomers can essentially freeze the motion of the atmosphere. This process, called lucky imaging, works on the idea that some of those images will catch a brief moment when the air is unusually still. Those sharp frames can be combined into a clearer picture. There are also image processing algorithms that can help clean up twinkling effects after the fact. Computers are remarkably good at spotting patterns in noisy data. So even if the stars are flickering in real life, software can help recreate what they would look like if the atmosphere weren't getting in the way. And let's not forget about radio astronomy, which deals with radio waves rather than visible light. Radio waves are much less affected by the atmosphere. So telescopes like the Very Large Array in New Mexico or the Massive Dish in China's Fast Observatory can observe the universe without worrying about twinkling at all. It's a different kind of astronomy, but one that complements what we learn from visible light. Still, there's something lovely about the fact that all of this effort, thousands of scientists, billions of dollars, decades of development, is aimed at seeing the stars as they truly are. All because of a simple, twinkling illusion caused by the air above our heads. In a way, twinkling reminds us of our perspective. It's not the stars that are changing. It's us, or rather the thin layer of life sustaining air we live in. We're the ones inside the snow globe. The stars are just shining steadily, unaffected, patient. That's part of what makes astronomy so magical. It's not just about looking outward. It's about understanding where we are in the grand scheme of things. We watch the sky not only to learn about distant galaxies, but to better understand the air we breathe, the ground we stand on, and the nature of our own perception. So, the next time you see a star twinkle, you'll know exactly what's happening. You'll understand the physics, the history, the technology. But maybe, just maybe, you'll also smile at the fact that something so small, just a shimmer in the sky, can lead us to launch telescopes into orbit, build mirror systems that move faster than thought, and reach deeper into space than we ever dreamed. That's a lot of ambition, all thanks to a little bit of twinkle. Let's take a moment to shift our gaze, not just outward toward the stars, but inward toward ourselves. Because while science gives us all the tools to explain why stars twinkle, there's another part of the story that's just as important. How we experience it. The psychology of stargazing. There's something timeless about looking up at the night sky. It's a habit so ancient, so universally human that it almost feels wired into us. Long before cities, smartphones, or electric light, there were people lying on their backs watching the stars shimmer overhead. And remarkably, despite all that has changed, the feeling of awe that comes from stargazing hasn't faded one bit. It's calming. It's quiet. It slows you down in a world that seems to run on fast forward. But why does it feel that way? What's actually happening in your mind and body when you lie back? Look up and let the stars wash over you. Let's start with something simple but powerful. Awe. Psychological studies have shown that experiencing awe, whether from looking at a vast landscape, a towering mountain, or yes, the night sky, has measurable effects on your brain. It can lower activity in the parts of your brain associated with self-focus and ego. In other words, when you feel awe, you feel smaller. And strangely, that makes people happier. Why? Because it helps put your worries in perspective. That awkward email you sent this morning, that looming deadline under a sky filled with ancient starlight, those things tend to shrink a little. Not because they don't matter, but because they're just one tiny part of a much bigger picture. The stars remind us that we're not the center of the universe, and somehow that feels like a relief. And then there's the effect on your nervous system. Stargazing often happens in quiet, dark environments, places where you're naturally more relaxed. When you're outside at night, breathing in cool air and focusing on something far away, your body begins to shift into what's known as the parasympathetic state. That's the rest and digest mode. Your heart rate slows, your muscles relax, your blood pressure drops. It's the opposite of the fight-or-flight stress response. In short, stargazing can make your body physically calmer. Even your eyes play a part. When you look at something distant like stars, your eyes shift away from the close focus mode they use during screen time. That helps reduce eye strain and mental fatigue. It's like a reset button for your senses. And if you're lying on your back while stargazing, even better. Your posture naturally opens up your chest and encourages deep, even breathing. Of course, stargazing also does something to your thoughts. There's something about watching stars twinkle, something quiet and rhythmic that invites daydreaming or night dreaming. Really, your thoughts start to slow down, unspool wonder. You're not solving problems or making lists. You're just floating, drifting gently between wonder and calm. In fact, some researchers believe that stargazing can function a bit like mindfulness meditation. You're focusing your attention not on your breath or your body, but on something vast and beautiful. You become present without trying. And unlike meditation, stargazing doesn't require any special practice. You don't need training or discipline. You just need a sky. This mental stillness has real psychological benefits. Studies have found that regular exposure to nature, especially night skies, can reduce symptoms of anxiety and depression. It helps with emotional regulation, improves sleep, and enhances feelings of connectedness to others, to the world, and even to the universe. And speaking of sleep, there's good news there too. Stargazing can help reset your circadian rhythm. When you spend time under natural night light instead of artificial indoor light, your body starts to release melatonin at the right time. That's the hormone that helps you feel sleepy. So, watching the stars doesn't just feel relaxing, it can literally prepare your body for rest, which makes twinkling stars the perfect bedtime companions. Now, let's add a little humor to all this science. Because if there's one thing that's both deeply cosmic and delightfully silly, it's the fact that some of us will stare at the stars and think profound thoughts about time and space, while others will say, that one looks like a potato, or I think I saw a UFO. And that's okay. The sky is generous. It meets you wherever you are. Whether you're contemplating your place in the cosmos or just enjoying the sparkle, the stars twinkle all the same. It's also worth noting that stargazing is a wonderfully low-pressure activity. There's no right or wrong way to do it. You don't need to know the names of the constellations. You don't need a telescope or a star chart or an app. You can just look up. That's it. And even if you're in a place with light pollution and you can only see a handful of stars, those few points of light can still work their quiet magic. Sometimes less is more. One lonely twinkling star is enough to start a whole train of thought, one that takes you far beyond where you are. And finally, there's something deeply connective about stargazing. You may be alone in your backyard or on a balcony, or curled up on a rooftop, but you're never really alone. Somewhere else in the world, someone else is probably doing the same thing, watching the same stars, seeing the same twinkle. They might be halfway around the globe, or just a few towns away, but they're part of the same silent conversation. It's one of the few experiences that feels both personal and universal. The stars belong to all of us, and yet each twinkle feels like a private moment, a secret flicker of beauty meant just for you. So, the next time you feel overwhelmed or restless or just too full of thoughts, try looking up. Find a star, any star, and let your eyes rest on it. Watch it shimmer gently and unpredictably. Let your breath slow. Let your mind quiet. Let yourself feel small and vast and safe all at the same time. Because in that moment, you're not just stargazing. You're syncing up with something ancient, something bigger than your to-do list, bigger than your stress, bigger than anything happening on Earth. You're participating in one of the oldest, simplest, and most soothing rituals we know. And all it takes is a single twinkle. So far, we've looked at twinkling stars from our earthly perspective through the lens of science, myth, and even the calming effects on the human mind. But what if we changed the view? What if we left Earth behind and took our stargazing somewhere else? Would stars still twinkle on Mars, or the Moon, or from the deck of a spacecraft floating somewhere in deep space? To answer that, we need to remember exactly what causes the twinkle in the first place. Stars twinkle because their light passes through Earth's atmosphere, which is full of swirling air layers, temperature gradients, and varying densities. These invisible changes bend the light, causing it to dance and shimmer before it reaches our eyes. Remove the atmosphere, and the twinkle disappears. So, if you were standing on the moon, where there is no real atmosphere to speak of, what would you see? The answer is stars that don't twinkle at all. From the lunar surface, the sky is pitch black. Even during the day, with no atmospheric scattering of sunlight, the stars shine steadily and silently, completely unaffected by turbulence or distortion. They don't flicker or shift color. They simply glow. This is true not only for the moon, But for any airless celestial body, Mercury, most asteroids, even many of Jupiter's moons, anywhere there's no atmosphere, stars appear exactly as they are, fixed, unwavering, and still. Now, let's take a short hop to Mars. Mars does have an atmosphere, though it's much thinner than Earth's, about 1% as dense. It's mostly made of carbon dioxide, and it's far less turbulent than our own atmospheric soup. So would stars twinkle on Mars? Sort of. The thin Martian atmosphere can cause a tiny bit of twinkling, especially when looking near the horizon, where the light has to pass through more air, but the effect would be far less dramatic than what we see from Earth. Most stars would appear steady to the naked eye, with perhaps the occasional gentle flicker. You'd have to watch very closely to notice it. In fact, early simulations by scientists suggest that if you were standing on Mars during a calm night, the stars would seem surprisingly stable. It would be like stargazing from a high mountain on Earth, but even clearer, less flicker, less distortion, just stars pining with their ancient light more quietly than we've ever seen them. And what about planets on Mars? Well, just like here on Earth, planets wouldn't twinkle much, but the effect would be even more muted than on Earth. Planets would look especially calm and steady against the Martian skin. Now, imagine leaving planetary surfaces entirely and stepping aboard a spacecraft orbiting the Earth or traveling even farther out. Once you're above the atmosphere, the entire twinkling phenomenon vanishes. Astronauts aboard the International Space Station, for example, see the stars as sharp and unwavering. No twinkle, no shimmer, just dots of light, perfectly still like sequins stitched into a cosmic quilt. Of course, this also means they don't get to enjoy that. Familiar poetic sparkle. The twinkle is something uniquely earthly, a side effect of our own atmosphere, a product of our particular way of being situated in the universe. It's something we share with all life that's ever lived here. In a sense, twinkling isn't a universal feature of the stars. It's a feature of our point of view. The stars themselves are indifferent to whether we see them shimmer. They shine as they always have, sending out light in every direction. But we, perched here on a planet wrapped in moving air, add our own subtle signature to the view. But now, let's wander even further beyond our solar system to a distant exoplanet orbiting a star far away. What would the night sky look like there? Well, it depends entirely on that planet's atmosphere. If it has a thick, turbulent atmosphere like Earth's, our light would twinkle just the same. If the air is dense but calm, like perhaps on a gas giant moon, you might get minimal shimmer. And if the planet has no atmosphere at all, the stars would again appear perfectly steady. Interestingly, some researchers have speculated about the color of alien skies based on the composition of exoplanet atmospheres. Imagine a planet with a sky tinted green or deep red or golden orange. The scattering of light would change, and so might the character of the twinkle, how quickly it flickers, what colors shimmer most, how distorted the light becomes. In some hypothetical atmospheres, the twinkling might be more intense than anything we've ever seen. In others, it might be completely absent. It all comes down to the temperature, pressure, and motion, fluid dynamics on a planetary scale. It's one of those quiet questions scientists love to ask. Not just what exists out there, but what it looks like to someone standing on the surface. What would starlight feel like on an alien world? What stories would another species tell about the sky? Would they even have a word for twinkling? Back here on Earth, the uniqueness of our atmosphere is often taken for granted. But it's worth remembering that the shimmer of the stars, the twinkle that inspires lullabies and paintings and late-night walks, isn't a cosmic guarantee. It's a local phenomenon, a side effect, a kind of optical accent in the language of light. And the idea that somewhere on another world, a curious observer might look up and see the stars shine in perfect stillness. Well, that's both beautiful and a little eerie, because twinkling, for all its scientific causes, feels like something deeply human. It's part of how we recognize the night sky, part of how we connect to the stars emotionally, not just intellectually. It adds a softness, a rhythm, a kind of gentle heartbeat to the heavens. So yes, stars can twinkle elsewhere, but only if the conditions are just right. And on most worlds, they probably don't. They shine as they always have. But the dance, the glittering, flickering, ever so slightly mischievous dance, is a performance reserved for our stage. It's a reminder that the universe doesn't always need to be altered to be appreciated. Sometimes the magic comes from the lens through which we see it. So the next time you lie beneath a starry sky and watch those tiny lights twinkle, know that you're witnessing something rare. Not because the stars are unusual, but because you are. Because this planet, this atmosphere, this particular swirl of air and light and perspective is giving you a show that few others in the cosmos might ever see. Twinkling, it turns out, is one of Earth's greatest special effects, and we get front row seats. And so here we are at the end of our journey. Through the night sky, we've unraveled the science behind that gentle shimmer, explored the layers of air that dance above us, followed photons across the universe, and wandered into ancient myths and faraway planets, all sparked by a single simple question. Why do stars twinkle? We've seen how the answer is both beautifully straightforward and endlessly complex. It's the atmosphere, yes, but also the history, the perspective, the emotion, and the imagination that we bring to the stars when we look up. The twinkle is caused by shifting air, but the meaning we find in it, that's entirely human. Somewhere tonight, light from a distant star is just now reaching Earth, filtered through a unique little pocket of sky, flickering gently as it lands in your eye. And maybe, just maybe, that tiny glimmer brings with it a little sense of peace, a little quiet, a moment of wonder, something to hold on to even as the rest of the world moves on. So before you drift off, let me ask again, where in the world are you watching from? What time is it where you are? Right now? Are you tucked in, just settling down, or maybe already floating somewhere between thoughts and dreams? Wherever you are, I hope this video has helped bring a little calm, a little clarity, and a little curiosity to your evening. And if you've enjoyed our starlit stroll, I'd be honored if you left a like, maybe subscribed, or shared where you're watching from in the comments below. After all, the sky belongs to all of us. And even though the stars shine for everyone, the twinkle, that little wink from the cosmos, is just for you. Sleep well, and may your dreams be filled with steady light and soft shimmer.